Okay, folks, later in working with differential equations, being able to understand complex numbers will be important. So let's start by defining the complex numbers. It's the set that we denote with this kind of funny looking C here, and it consists of all quantities a plus bi, where a and b are real numbers, subject to some rules, okay? And there are rules for equality, addition, and multiplication. The equality rule says a plus bi and c plus di are equal only if a equals c and b equals d. The addition says that when you add a plus bi to c plus di, you add the stuff without the i's together, and then you add the stuff with the i's together and group it with an I. And then there's a rule for multiplication that's kind of complicated. I won't read it out loud. But these are the sorts of things you would never memorize, right? So the significance of I is the following. If you take a complex number, a plus bi, and take another one, c plus di, and you set a equals c equals 0 and b equals d equals 1, you find that you're multiplying I times I, and if you use the multiplication rule above, you find that it equals -1. So that says I squared equals -1, and therefore I is the square root of -1. And that's a common way you'll see complex numbers defined. Numbers of the form a plus bi, where I is the square root of -1, and that understanding gives rise to these rules for equality, addition, and multiplication. So for a complex number a plus bi, a is called the real part of z, written real of z, and b is called the imaginary part of z, written like this, im of z. And you can take note that the real numbers are included in the complex numbers just by setting the b, the part in front of the I, equal to 0. And many of the rules for real numbers hold for complex numbers too. So commutativity of addition and multiplication, associativity, the distributive law, the additive identity is still 0, the multiplicative identity is still 1, and so forth. You'll also want to have a visual interpretation of the complex numbers, and you can picture the complex numbers as points in the plane, right? So if z is a plus bi, we kind of map that to the ordered pair a comma b, and we plot it, and the horizontal axis here is called the real axis. It keeps track of the size of the real part of the complex number, and then the imaginary part is plotted on the vertical axis. And this is called the complex plane. We can go ahead and instead of thinking of points, sometimes we can think of vectors. So the complex number z equals a plus bi gets plotted as the vector ab. So that's the vector pointing from the origin to the point a comma b. And these are fairly interchangeable ways of thinking about things, but for performing arithmetic and other operations on complex numbers, sometimes you're going to find that the kind of vector idea is more useful. All right, thanks for listening.